Hey guys, Mr. Gagnon again. Okay, so we're getting into the real physics here. We're starting our unit of kinematics, and when we think of the term kinematics, the word stems kine, which means movement, and matics is the calculation of. So movement and then calculation of. Kinematics, movement and the calculation of. So our topic here is the calculation of movement, because we're, think, our life consists of movement. Okay, that's like a fundamental thing that we look at, is movement. And in the last section, we learned how to calculate speed. And just to recap, okay, we learned that speed is the distance divided by the time. And distance is a fundamental quantity. This is a fundamental quantity which really can't be described unless compared to other things. So the time can be referred to as this delta t, which is change in time. The distance can be also something as change in distance. So now we're looking at two different distances. So like distance final minus distance initial over time final minus time initial. Okay, so we've got a formula that we can use here. Generally, we started at 0, so we just have to look at one of these. But if you're really looking at it, okay, we are comparing two distances, and we are comparing two times. So we're changing the fundamental into something that we can work with. And in kinematics, okay, we have a set of three master formulas which tell us what we need to do. Now, what we're going to do first is take a peek at something called average speed of a trip. Okay, and I'll probably tell you a story in class about how, when I bought my first new car, it had this cool feature on it, which all cars have now, but it tells you what your average speed is throughout an entire trip. So I visited a friend in Tennessee, and my average speed was about 32 miles an hour. Now I looked at it, and I was a little confused because I knew I'd been driving like 60 or 70 miles an hour on the highway, and I thought to myself, well, why is it down so low? Well, that included all the stops. That included the stop to the gas station, the stop to buy snacks, to fill up fuel, to use the bathroom. That was all part of that average speed calculation. Okay, so I'm going to show you guys how to get the average speed of a trip, a 3-segment trip. Okay, so this might be something that you will see a little later, as well as far as some problems in the problem sets. So this is something you want to take down. If we have, a label on the top, this is the segment of a trip. This is a distance of a trip, of a segment. This is a time and speed. So if we were to put this into a data table, okay, which I'll have you guys do, that way we can calculate some things here. Okay, distance will be measured in meters, times in seconds, and speeds in meters per second. Okay, we already learned how to calculate distances from time and speed. We already learned to calculate time from speed and distance. We learned how to calculate speed from distance and time. So like the first segment and then the second segment and the third segment of the trip, we're going to make almost like a story to go along with it. So here's the story. Okay, you ride your bike home from school by way of your friend's house. It takes you 420 seconds. This is the first segment we're talking about. It takes you 420 seconds to travel 2,500 meters to his house. Now, generally, what I would say as far as the time goes, I would say it takes 7 minutes. But I've already go ahead and I've changed that to seconds, and I've converted. And the 2,500 meters would be written as 2.5 kilometers, but I already changed it to meters. You spend now, okay, so you finished the first segment of the trip. Okay, now you spend 10 minutes, which is 600 seconds, at his house. Okay, before traveling 3,500 meters to your house in 540 seconds. So look, when you were at his house, were you moving a distance? No, you weren't moving a distance. So the calculation here, okay, does not involve you coming up with the speeds of all these and averaging them. Okay, you would think that it would, but it's not how it's done. So all you're going to need to do is to get the average speed is distance 1 plus distance 2 plus distance 3. That means all the distances divided by time 1 plus time 2 plus time 3. So you're just going to do distance total over time total, and you've got your answer. So if I just plug in the calculator, okay, and you guys should at this point be having a calculator that you're comfortable with, whether it's in the classroom or at home. So I'm going to take all the distances, 2,500 plus 0 plus 3,500. Okay, so that's 6,000, okay, meters. And then the total time, 420 plus 600 plus 540 is 1,560 seconds. So to get that average speed, it's 6,000 divided by 1,560. Okay, so I end up with an overall average speed of the trip of 3.8 meters per second. Okay, and this is how we calculate the average speed of a trip. So the average is the distance 1, distance 2, distance 3 over time 1, time 2, and time 3, or otherwise known as distance total over the time total. Okay, nowhere do you have to calculate the speed of each segment unless you're asked to find the speed of segment 1, which you can go ahead and take as d over t. Okay, d over t, d over t. Okay, so that'll be how you calculate the average speed of a trip.